So I'm Sam Warzel. I'm the CEO and one of the co-founders of Octopart. Octopart is a search engine for electronic components. We take inventory and stocking pricing information from about 200 different component distributors, and you can find information about how much parts cost, how much they used to cost, data sheets, technical specs, all that kind of stuff. Today I'm going to talk about some best practices for component purchasing as you are building hardware, both what the best practices are today and also where we see some trends going around purchasing down the road in the future. So briefly, first I'm going to talk at a very high level about the product development lifecycle and the role of the BOM, the bill of materials. And then I'm going to talk about some of the best practices along that product development lifecycle, and then we'll talk about some future stuff. So, product development lifecycle. You're building a new hardware product. First, you come up with an idea, and you start working on the design. You sketch out the circuit. You start thinking about what components am I going to use in this design. Pretty soon, you're ready. You can build a prototype. You can start buying parts. You've got something that works, and you see what works, what doesn't work, and you go back and you work on the design again. All the while, you're keeping a list of what are the components that I'm using. In the beginning, you're really just trying to get something that works, but really, you should be thinking at this stage about what are the right parts to use, what parts are going to be most useful when it comes to going to production. And when you do get into production, you don't want to get into a situation where you've chosen parts that are going to throw you for a loop, and I'll get into that in a second. And so here the photograph is of the Pebble watch, design, specifications, prototypes, and then the final finished product. So like I said, along this whole path is the BOM, the bill of materials. Now, what you see here are two BOMs. One of them uses our bill of materials manager tool, and you can check it out on octopart.com. Basically, we provide additional supply chain information, but you can also use an Excel spreadsheet like you see on the right. The BOM is going to be with you throughout this whole cycle, and it's important that you keep in mind a couple of things as you start to develop it. So you're in the design cycle. What are things to keep in mind as you're doing component selection? A couple acronyms to keep in mind. PCN stands for Product Change Notice. This is a document that manufacturers of components will publish if the products that they're making undergo some material change. What you don't want to happen is to design in a component, you get to production, they put the part in, and it's actually not what you anticipated. These mistakes become very expensive, very time-consuming very quickly. Other acronyms, other things to keep in mind are the EOL, NR&D. If the manufacturer is telling you don't use this part, then don't use that part. Find out what the replacement part is. Make sure the parts that you're designing, even at the prototype stage, are parts that are in production. And lastly, make sure that the parts that you're designing in, ideally, are not single sourced if you can avoid it. You don't want to get into a situation where you find just the perfect part that's hard to find, but it scratches that engineering itch that we all have to find the perfect thing. If you can find a part that is a little bit more generic, is going to be widely available in the supply chain, you will thank me later when it comes to production that you used that part. So prototyping. The key to prototyping is speed, because you want to have as many iterations of that prototype design cycle so that you can get your product ready for production. So you can find them on Octopart, you can go right to their website, they'll ship overnight. You also, at this stage, you can also consider buying components directly from the manufacturer. And this you might think is a little bit unusual, that maybe you think only big companies like Apple are going direct. But actually what you'll find is that some chip companies will sell you parts direct, even in small volumes. You can get free samples if you ask really nicely. The key with the component manufacturers, especially the semiconductor companies, is to convince them that the product that you're building is going to be huge, and that you are either going to go with them or you're going to go with one of their competitors, because it's in their interest to get their parts designed into your product at this stage. And to help them do that, they'll give you free parts, and you can start building those relationships that are going to be very important when you start going into volume production. Another resource for doing prototyping really quickly are contract manufacturers. Now, you might think of contract manufacturers like Nathan mentioned in China, doing very huge volumes. There's also a lot of contract manufacturers in the US that specialize in small volumes. They specialize in things like medical devices, communications equipment, military equipment. There is a very sophisticated ecosystem of domestic contract manufacturers. In fact, here in New York City, there's a Refactory out of Brooklyn, contract manufacturer, and they will do small runs. They can help you get going with prototypes really quickly. It can be a little bit expensive, but really at this stage, the name of the game is speed. So you've got your prototype, gone through a couple of these cycles, and you're ready to go into production. So Nathan gave a great talk about going to China for manufacturing. There's depending on the volumes that you're building, if the runs are a little bit smaller, if they're specialty devices, medical devices especially, you can do your contract manufacturing here in the US. And there's a couple different kinds of contract manufacturing paradigms. The difference between turnkey contract manufacturing and consignment. With turnkey, it's really like it sounds. You give them the design specs, they do the purchasing, that can be a great time saver, but you can also save a lot of money if you take on some of the purchasing responsibility yourself. And this goes back to building those relationships with the manufacturers, and also building relationships with component distributors too. You might think that what you see on the web when you go to a distributor website is the final price for the part. A lot of times it's not. If you can, like I said, convince the manufacturer that your product is really going to drive a lot of volume, you can get their distributor to give you a better price. Or if you can convince the distributor by going through a sales representative, that sales representative has channels into the manufacturer and can get you special pricing. Distributors that do this quite frequently are places like Arrow and Avnet. They push large volumes through online distribution, and they have an army of salespeople whose job this is to find the next hot hardware startup that's going to push volumes and to get you really good pricing. So just because it seems like they have a website and that's it, no, they have human beings that are waiting to take your call. I think I covered the production aspects. So this is kind of how things work today. But as I come to a lot of these meetups, I see the amazing tools that are being built. I start thinking about what's it going to be like tomorrow, and I think things are changing pretty quickly. We talk to a lot of hardware startups, a lot of designers, and a lot of contract manufacturers who use Octopart. And one of the most common complaints that I hear from designers, especially designers that are new to this game, is that they don't know what parts to choose. If you go to Octopart, we have 30 million components in our database. There's a lot of components out there. How do you know what parts are appropriate? And you go to talk to the contract manufacturers, and they get frustrated because they get a bill of materials from a hardware startup, and they've chosen parts that are not procurable at the quantities they need. Or if they are procurable, it's not easy to get them. So we thought about this problem, and we thought, well, wouldn't it be great if there was a list of commonly used parts, and we kind of scoped down the domain of connected device applications. It seems that's what a lot of the types of the devices that people in this room are building. They all have the same functionality, right? They connect to Wi-Fi, they use Bluetooth, low energy, they have a bunch of sensors on them, they have some connectors maybe, some memory, a lot of passive components. So what we've done actually is collect a list of these components, about 200 of them, and we keep iterating on this list to find out what is that minimum set of parts that's going to allow it to make it possible for design to happen much more efficiently. On the contract manufacturer side, we solved their problem. They're thrilled by this idea. Rather than having to go through tons of Excel spreadsheets just to give quotations, they could take advantage of economies of scale and stock these parts and have them ready for you when you're ready to go into prototyping or production. And so it's an interesting concept. I think that those kinds of efforts are going to change the face of procurement in the next couple of years. One level higher in the abstraction hierarchy is a concept of common design libraries. I know that a lot of semiconductor companies now are doing a great job of putting application notes out there, showing you how you can integrate these technologies that they know you're going to put into your products, things like Wi-Fi, things like Bluetooth. And there are contract manufacturers, I mentioned Refactory, they are working on some of these building block approaches to doing hardware design. And I think that goes along with this trend of hardware startups being started by folks who might not have an electrical engineering degree and many years of experience working for a big electronics manufacturing company. They might be people with an idea, and with things like Arduino, it's really opened up prototyping. I think with a lot of these new ways about thinking about components and component sourcing, it's going to open up not just the prototyping, but also manufacturing, and make it possible for even more people to get involved in this space. Another thing that's happening is it's getting easier to build prototypes. Whereas in the past, if you wanted to get a prototype that wasn't just an Arduino with some wires hanging off of it, which is a really good way to get started, I'm not saying it is, but the next step is you do want to have a printed circuit board. You want to get something that is starting to look like your product. And you'd have to get a printed circuit board made in low volumes, which is very expensive to do. You would need to either assemble it by hand, which can be very tedious, or send it out to a contract manufacturer to get assembled on their pick-and-place machine, which is time-consuming. Both of these processes are starting to become achievable on the desktop. The Cartesian guys are here. They're building a PCB printer that prints conductive ink on PCBs, and they're not the only ones working on that. There's a number of companies doing that. There's a number of companies doing pick-and-place on the desktop. And I think that there's an analog that's happening in electronics, PCB assembly, and PCB manufacturing that happened with 3D printing over the last couple of years. And I feel like we are where 3D printing was about 3 to 5 years ago. So what does that mean? Well, it means that prototypes are going to happen much quicker. The prototypes happen quicker, products come to market quicker, it opens up the market, and it's going to be really exciting to see what happens in this prototyping environment in the next couple of years. I think another place where Octopart can be helpful is providing better supply chain visibility tools. I showed a quick slide of our bill of materials manager, and you can see on the left-hand side there are some color codes which give you at-a-glance visibility into what the supply chain looks like for that line item. Red means that there's no availability for that part. Green means there's multiple authorized distributors. And there's other things we can do. Since we get data from over 200 component distributors, we have this global view of what stock looks like over many different parts. It helps us define the common parts library. We can do things like showing historical pricing and availability graphs to help contract manufacturers and purchasers get more information and make smarter sourcing decisions. So I think the future is really exciting in this space. Things are going to start happening faster, decisions are going to be made smarter, and I'm excited. So thank you very much for your attention. I also just wanted to mention Octopart, we're based here in New York City. We're a team of 15. We're hiring salespeople, hiring people who are electrical engineers who are interested in common parts library, software engineers. So if you're interested in that, shoot us an email to jobs@octopart.com, and you can get in touch with me at sam@octopart.com as well. Thanks.
Cool. All right, some questions from Sam.
So, how do you guys build sort of parametric search that almost
Yeah, the question was how do we build parametric search when we have components for all over the place? And yes, it is a complicated problem. What we do at Octopart is we built these back-end data normalization systems to take in data from many different sources and normalize it. And so we do have a unified database of component data, even though we do take in data, lots of different formats from hundreds of different sources.
Do you take
We do. Yeah, we do. Yeah, we get emails like that all the time. Yeah.
Do you sell parts?
Do we sell parts? No. No, we will show you which distributor sells the parts, and you can click to their website and make a purchase. We're kind of like Kayak, right? Kayak doesn't have airplanes, so they'll tell you where to go.
Is that how you make money?
Yep, that's the main way we make money, is sending the referrals to distributors. So keep clicking those links, but make sure you buy. Yeah.
Sim, I haven't had a look at your common parts library yet, but I was wondering how big is that at the moment and how quickly you iterated through it?
Yeah, the question is, how big is our common parts library? Right now, it's about I think it's about 250 parts right now. Most of those parts are passive components because to build anything, you're going to need resistors and capacitors, and you need them in a wide variety of values. We are focusing on some of the smaller surface mount sizes, so it is a constrained set of parts, and that's by design.
That's the idea, to get it to be as small as possible. So
Right. Right. Yep.
Have you extracted your parts data to the next level, so you know these suppliers and you know their clients, that this one works with Apple, this one with Samsung, based on what parts they have, try to figure out what they're building down the pipeline?
No, but we do have a lot of this parts data, and you can imagine that we do have information about some trends that are happening in the industry, what people are interested in looking at. There's a lot of analysis that we can do on that kind of bulk queries and bulk average data across many parts. And we have looked at that kind of stuff. I'm not quite ready to start a hedge fund based on that yet, but I've thought about it. Yeah, we actually do have a bunch of blogs in that vein. We just had a blog last week about how we chose resistor values for the common parts library. What we did is we looked at all the resistors from this certain surface mount size that we had, and we noticed really interesting patterns about what values of resistors the distributors carry. And I won't give you the punchline, but it actually doesn't correspond to the standard resistor values. It's a long story. Check out the blog. But yeah, there's tons of blogs that could be written about that. That's just looking at the resistors of one size. But we get requests from academics sometimes. There are people doing PhDs in component manufacturing, and they're interested in trends having to do with memory sizes and speeds of processors, that kind of thing. There's a lot in there.
All right, well, let's give a round of applause.